Hi, this is Math 227 Statistics. Today we talk about the examples of Chapter 4 homework. First question, 3 coins are tossed. Answer the following regarding the probability experiment. A. Use a tree diagram to find the sample space. We toss the first coin, we'll get the outcome either head or tail. Then toss the second coin, we will get outcome either head or tail. Head or tail. Then we toss third coin, we'll get the outcome either head or tail. So the outcomes is head, head, head. Head, head, tail. Head, tail, head. Head, tail, tail. Head, tail, head, head. Tail, head, tail. Tail, tail, head. Tail, tail, tail. Total is 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes in the sample space. The B, find the probability of getting exactly 2 heads. Your homework is exactly 1 head. Example, given this is example, exactly 2 heads. So probability of 2 heads equals total 8 outcomes. How many outcomes are 2 heads? On the tree diagram, you can see head, head, tail. Or head, tail, head. Or tail, head, head. Those 3 outcomes are exactly 2 heads. So probability is 3/8. And C, find the probability of getting at least 1 head. At least 1 head. So it's 1 head or more than 1 head. So probability of at least 1 head is equal to probability of 1 head add probability of 2 heads add probability of 3 heads. You can use tree diagram, or you can list over here 0 head, no heads, 3 are tails, 3 outcomes are tails, so tail, tail. 1 head, so it's a head, tail, tail, or tail, head, tail, 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 head. Those are exactly 1 head. 2 heads, head, head, tail, or head, tail, head, or tail, head, head. Those 3 outcomes are exactly 2 heads. 3 heads, they all heads, head, head, head. So probability of 1 head has 3 outcomes, so 3 out of 8. Probability of 2 heads has 3 outcomes, 3 out of 8. Probability of 3 heads is 1 outcome, 1 out of 8. Add together, denominator is 8, numerator 3 add 3 add 1 is 7, 8. Alternatively, there's another way, faster way. Find probability of at least 1 head is equal to 1. 1 is 8 out of 8 minus probability of 0 head. Because at least 1 means 1 probability of 1 head plus probability 2 head as probability 3 head. So it's equal to total is 1. 8 out of 8 minus probability of 0 head. 0 head is only 1 outcome. So 1 out of 8 probability. And the 1 is 8/8. Minus 1/8 is 7/8. Next one, D. Find the probability of getting at most 2 tails. At most 2 tails. Probability of at most 2 tails. So the maximum is 2 tails. Is either 2 tails or below 2 tails. So equal to probability of 0 tail plus probability of 1 tail plus probability of 2 tails. So you can list out about the tails. 0 tails, those are 3 are heads, 0 tails. 1 tail, only 1 tail, only 1 tail, only 1 tail. So 3 outcomes. And 2 tails has 2 tail, 2 tail, 2 tail. So 3 outcomes has 2 tails. 3 tails, tail, tail, tail. So probability of 0 tails, no tails, it's 1 of it, is 1 out of 8. Probability of 1 tail is 3 of it, 3/8. Probability of 2 tails is 3 of it, 3 out of 8. Add together is 7/8. Alternatively, probability of at least 2 tails, is less than or equal to 2 tails, either 0 or 1 or 2, 0 or 1 or 2. So total is 1. 1 is 8 out of 8. And you minus this probability of 3 tails. So you will get this part. So 1 minus 1 of it, 1/8. A over A minus 1A is 7/8. Second question. Answer the following regarding an ordinary deck of cards. A. Find what is the probability of draw a diamond or a number 9. So first of all, we need to draw a deck of cards. A deck of cards has diamond, heart, club, and the spade. Diamond is red, heart is red, club and the spade both are black. Have the numbers. Ace is number 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and the king. So this side has 13, 1 through 13, and this side has 4. 13 times 4, total 52 cards. 13 times 4, total 52 cards. The first question, find out the probability either diamond or number 9 is equal to, we are going to use a formula. You can look at your formula. This we call exclusive. There's exclusive event or independent event, or if not mutually exclusive, also called dependent event. And here we are going to use addition rule. Probability of A or B is equal probability of A plus probability of B and minus probability of A and B. We are going to use this formula. So A event, for this question, A event is a diamond, get a diamond. B event is get a number 9. And use this formula, we'll get the probability of a diamond or 9 is equal to probability of a diamond plus probability of 9 minus probability of a diamond and a 9. Probability of A or B equal probability of A plus probability of B minus probability of A and B. A event is diamond. B event is get number 9. So, how many are diamond cards? This one, diamond, has 1, 2, 3, 4 until 13. 13 diamond cards. So probability is 13 out of total 52 cards, plus probability of 9, number 9. How many are number 9 card? Number 9 card. Here it's 1, 2, 3, 4. 4, number 9 card. 4 out of 52. And minus diamond and the number 9. What is the diamond and the number 9? You look at a deck of cards. You got the diamond and the number 9 intersection. Only one car is diamond and the number 9. Diamond and the number 9. Only one car is diamond and the number 9. So probability get diamond and the number 9 is 1 out of 52. Then denominator is same denominator is 52. Numerator 13 add 4 minus 1 is 16. And reduce common factor. 16 divided by 4 get 4. 52 divided by 4 get 13. So probability is 4 over 13. Next one. B. What is the probability of drawing a jack or a queen or a king? So we are looking for probability of a jack or queen or king. Since the jack and the queen and the king, they are mutually exclusive. They are we call independent event. Because jack have 4 cards, king has 4 cards, queen has 4 cards, king has 4 cards. They are independent. There's no common area. So we call mutually exclusive. So we are going to use the formula. In the formula sheet, it's here say exclusive independent event. Addition rule is the probability of A or B equal probability of A plus probability of C. So use this addition rule. A and B are mutually exclusive independent event. Now here has 3 events. So will be probability of jack or probability of queen or probability of king is equal probability of jack plus probability of queen plus probability of king. They are mutually exclusive independent event. So equal to total 52 cards. Jack have 4 cards, 4 out of 52. King also 4 cards. Queen also 4 cards. King also 4 cards. So we add together 52 and 4 add 4 is 12. And cancel common factor 4. 12 divided by 4 is 3. 52 divided by 4 is 13. So it's 3 out of 13. It's the probability. And C, what is the probability of drawing an ace or a spade or a club? So those we are going to have 3 events. Ace, drawing an ace or spade or a club. So we are going to use the formula. The formula is not on the formula sheet, so I'm going to write down that formula. The formula is probability of A or B or C is equals probability of A plus probability of B plus probability of C minus probability of A and B minus probability of A and C minus probability of B and C plus probability of A and B and C. So it's 3 events. So this one, 3 events get an ace. So it's equal to probability of an ace plus probability of spade plus probability of club minus probability of ace and spade minus probability of ace and the club minus probability of spade and the club plus probability ace and spade and the club. So total 52 cards. How many are ace card? There's 4 ace card. Here ace 1, 2, 3, 4. 4 ace cards. So 4 out of 52 plus probability of spade. How many are spade card? And the spade here has 1 down to 13, have the 13 spade card, 13 out of 52, plus how many are club, probability of club, 13 card, is club card, out of 52, minus probability of ace and the spade, ace, this is the ace card, and the spade here, only one card, this card, ace and the spade, only one card. So it's 1 out of 52, minus probability of ace and the club. How many are ace and the club? Here it's ace and the club, intersection is this card. It's 1, 1 out of 52, minus probability of spade and the club. Here is a spade card. And this is a club card. Are there any card, spade and also club? That's impossible. So it's 0, 0 out of 52, plus probability of ace and the spade and the club. Probability of ace and the spade and the club. Are there any card? Is spade and also club and ace. There's no such card. So it's 0 out of 52. So we add together, denominator is 52. Numerator 4 as 13 minus 1 is 28. Cancel common factor 4. 28 divided by 4 is 7. 52 divided by 4 is 13. Then next one, the D. If a red suit is drawn, what is the probability that the card is a heart? So this we call conditional probability. D is about conditional probability. The formula is formula for conditional probability is probability of B given A is equal probability of A and B over probability of A. So we use that conditional probability formula. Probability of heart given red, under condition is red, is equal to probability of heart and red over probability of red. So how many cards are heart and red? So probability to get heart card. Heart is red card. Total has 13 heart and red card. So probability to get heart and red is 13 out of 52. And what is the probability of red card? Red card, there is a diamond, 13 red card, heart, 13 red card, total 26. 26 red card. So probability to get red card is 26 out of 52. And divided. So it's 13 over 52. Then times division, long division, change to multiplication, reciprocal, denominator reciprocal, 52 over 26, cancel 52, and 13 divided by 13 is 1, 26 divided by 13 is 2. The 2 have a 13 and 26, have a common factor 13, cancel. So remain 1 times 1, numerator is 1, denominator 1 times 2, 2. So probability is half at 50%. Then another example, probability of spade given red. So is equal to, this is another example, is a probability of spade and red over probability of red. That equal to probability of spade and red. The spade card. The spade card is a black card, never red. So there's no red spade card. So it's 0. 0 out of 52. Probability is 0. Probability of red is the same as here, is 26 card. 26 out of 52. Then you divide it. 0 over 52. Long division, change to multiplication. Reciprocal. 52 over 26. Cancel 52. Then 0 divided by 26 is 0. So it's 0% to get the probability is of the spade to get a spade card. Given condition is a red card. So E, if 4 cards are drawn without replacement, what is the probability that at least one of the card is a spade? 4 cards drawn, so at least one spade. So as we are looking for probability of at least one spade card. So that means you will get either 1 spade card or 2 spade card or 3 spade card or 4 spade card. So equal to total probability is 1 minus probability no spade card. Because you want its probability of 1 spade plus probability of 2 spades card plus probability of 3 spades card plus probability of 4 spades card. Equal to total is 100% minus probability of no spade card. So then 1 minus no spade card. You draw the first card and not spade. There are 13 spade card. There are 13 spades card. And those diamond, heart, and the club, they are not spades card. So there are 39. 13 add 13 add 13. 39 is a not spade card. So probability to get the card is not spade is 39 out of 52. That's the first card. Without replacement, do not put back in. Without replacement. So the first card do not put back in, remain total 51 card. In 51 card has how many are not spade card? Since you draw out 1 not spade card, so remain 38 spade, not spade card. So second, you got probability got not spade card is 38 over 51. And once you draw 2 not spade card out, so remain 50 card. When the third time you draw, and without replacement, do not put back into the deck. Then remain 52 cards. How many are not spade card? 37. Then continue. The fourth card you draw, without the 3 card, do not put back in. So remain 49 cards. And how many are not spades card? Since those 3 spade card take not spade card you take out, so remain 36 not spades card. So therefore it's 36 out of 49. And you figure out this and use calculator. Use calculator. You do. You can do. 1 minus parenthesis 39 times 38 times 37 times 36 parenthesis divided by parenthesis 52 times 51 times 50 times 49 parenthesis and hit enter. Then you will get the answer is 0.69618 and round up to 4 significant digits. So 1, 2, 3, 4, 4 significant digits. This digit is 8, more than 5. So round up. So get 0.6962. The third question about the mutually exclusive. Mutually exclusive. This one we call mutually exclusive. This is an event. The 2 events, they do not have the common occur area, no intersection area. We call the 2 events are mutually exclusive. If the 2 events have a common area, have a common area, which is both are occurred, we call not mutually exclusive. So the question asks, A, two events are mutually exclusive if they can both occur, true or false. If they can both occur, it's not mutually exclusive. So this one, if they can both occur, then the two events are mutually exclusive. I change it. Are mutually exclusive is false. Answer should be not mutually exclusive. So the B, two events are not mutually exclusive if they cannot both occur. Now, if they cannot both occur, which is this case, not both occur, then the two events are not mutually exclusive. If they cannot both occur, should be mutually exclusive. So here say, then the two events are not mutually exclusive. It's not true. So the two answer is false. Number 4, a student and a professor each choose a number between 1 and 4. 1 and 4 are both possible choices, including number 1 and the number 4. What is the probability that the two choose the same numbers? So you can list out this table. Student choose number 1, 2, 3, 4. Professor choose number 1, 2, 3, 4. So the outcome will be students get number 1, the professor get number 1. Students get number 1, professor get number 2. Students get number 1, professor get number 3. Students get number 1, professor get number 4. Or students get number 2, professor get number 1. Or 2, 2, 2, 3, 2, 4. 3, 1, 3, 2, 3, 3, 3, 4. 4, 1, 4, 2, 4, 3, 4, 4. And total, how many outcomes? It will be 4 times 4. Total 16 outcomes. And the question asks you the probability that the truths are the same number. So which is this? 1, 1, 2, 2, 3, 3, 4, 4. Those 4 outcomes are the same number. So numerate is 4 outcomes. 4 out of total 16. Total 16 outcomes. There are 4 are the same numbers. 4 outcomes are the same numbers. So probability to get the two choose, both the professor and the students get the same numbers is those 4 outcomes, 4 out of 16, and reduce, cancel common factor 4, get 1 quarter. Number 5, on a 5 question true false quiz. There's 5 questions, and they are true false quiz. Students guess each answer. What is the probability that the student gets at least one of the answer wrong? At least one of the answer wrong. That means 1 answer wrong, 2 answer wrong, 3 answer wrong, or 4 answer wrong, or 5 answer wrong add together. Is exactly the same as total probability is 1 minus probability of none are wrong. No, nothing are wrong. That is going to be probability at least 1 wrong. So none of the wrong, that means they all right. So 1 minus probability, all 5 questions are correct. So equal to 1 minus, first question right, probability is a half, 1/2, because true false question, only 2 choice. So the first question you guess right is 1/2. Second question is right, also 1/2. We want to be 5 questions right. So 1/2 times 1/2 times 1/2, total times 5 times. So 1/2 to the power 5. Now 2 to the power 5 is 1 minus 2 to the power 5 is 32. 2 times 2 times 2 times 2 times 2 is 32. 1 to the power 5 is 1. 2 to the power 5 is 32. So total is 32 out of 32, which is 1, minus 1 over 32. So subtraction, get 31 over 32. That's probability. The next question is die is rolled 3 times, and answer the following. A, find the probability of getting at least one odd number. At least one odd number. So roll the die 3 times. A die have 6 faces, has 6 numbers. So when you roll, probability of at least one odd is equal to, because you roll 3 times, at least one odd or 2 odd or 3 odd is equal to 1 minus probability of no odd number show up. So it's no odd, that means all the 3 times are even numbers. So it's 1 minus probability all 3 times are even. So 1 minus the first time even probability is what? It's because have a 6 number, there are the number is going to be 1, 2, 3, 4, 5, 6. Probability you got the even number. It's those are 3 are even number. 6 number, there's 3 number are even number. So probability get even number is 1/2, and probability to get odd number is also 135 odd number. 3 out of 6 is also 1/2. So probability to get you roll 3 times. First time you got even number is 1/2, and the second time roll also get even number is 1/2. Third time also 1/2. So it's all 3 times are even number is 1/2 times 1/2 times 1/2. So 1/2 to the power 3. So total is 1 minus 1 to the power 3 is 1. 2 to the power 3, 8. And 1 is 8 over 8. Minus 1, 8 is 7, 8. And the B, find the probability of getting a sum of 5. So you add those row 1, row 2, row 3. If the first row you got number 1, second row get number 2, number 1, the third row you should get number 3. 1 add 3 is the total sum. It's a 5. The first row get number 1, second row get number 2, the third row should be 2. Then the sum will be 5. 1 add 2 is a 5. Then first row is number 1, second row is 3. The third row should be 1. Add together 1 add 3 add 1, it's a 5. The first row, then you continue. If you go to 1, 4, then 0, that's impossible. There's no number 0. 1 add 4 add 0 is 5, but it's impossible. So you go add 1. Row 1 get 2. Row 2 get number 1. Then the third row should be 2. Then add together, it's a 5. Or the row 1 is 2. Then row 2 get 2. The third row should be 1. 2 add 2 add 1, it's a 5. Then you keep going on. 2, 3, and should be 0. But there's no number 0, so that's impossible. So we go another one, 3. The row 1 is 3. Second row is 1. Third row should be 1. Then sum will be 5. If you keep going on 3, 2, then that's 0. 3 add 2 add, there's 0, impossible. So that's all are. So there's 1, 2, 3, 4, 5, 6. 6 out of, because a sum is 5. There are how many outcomes? Should be 6 times 6. Because there's a first row has a 6 number, second row have a 6 number, times 6 number. Total is 216 outcomes. Out of 216 outcomes, and there's a here has a 1, 2, 3, 4, 5, 6. 6 out of 6 times 6 times 6. The total 216 outcomes. And you have 6 outcomes. The sum is number 5. And you cancel 1, 6. So answer is 1 out of 36. 1/36. Question 7. In a class, there are 17 juniors and 9 seniors. 5 of the seniors are female and 11 of the juniors are male. If a student is selected at random, find the probability of selecting the following. A junior or a female. So first of all, we have to create this table. And how to create this table is you put the junior and the senior. Here you put the and this junior and senior, male, female. Here say 17 junior, so put on the bottom, put junior have 17. And 9 senior. Senior has 9 seniors. 5 of the senior are female. Senior, female is a 5. So write 5 here. Senior and the female, 5. And the 11 of junior are males. Junior and the male, so this is 11. Then you do 17 minus 11, get 6. This is junior and the female. Then you do 9 minus 5 and get 4. That is the senior and the male. Then add together 11 add 4. Male has 15 males. 6 add 5, 11 is the females. Total 15 add 11, 26 total. Or you do 17 add 9, also 26. After create this table, then the question say, what's the probability of junior or female? This use the formula. The formula we call not mutually exclusive dependent events addition rule. Probability of A or B equal probability of A plus probability of B minus probability of A and B events. So the probability of junior or female is equal probability of junior plus probability of female minus probability of junior and the female. So probability of junior, total 26 in a class, 26. How many are junior? Junior, 17. 17 out of 26. Plus probability of female, total class 26. How many are female? Female, 11. 11 out of 26. Minus probability of junior and the female. Junior and the female has 6. So 6 out of 26. So denominator is 26. Numerator 17 add 11 add minus 6. We got 22 out of 26. And reduce common factor 2. So get 11 over 13. And B, a junior or a senior. So use the same formula, addition rule. Probability of junior or senior is equal probability of junior plus probability of senior minus probability of junior and the senior. How many are junior? 17 out of 26. How many are senior? 9. 9 out of 26. Minus probability of junior and senior. Are there any students is a junior and also senior? A student is junior, cannot be senior. A student is senior, cannot be a junior. So there's impossible. So there's no such students. So it's 0 out of 26 probability. Then you 17 add 9 is 26 out of 26. So equal 1. 100%. Because in this class, only junior and the senior. So you got one student, either junior or senior, probability is 100%. 100%. And the C, a junior who is a female. So that's just looking for probability of junior and the female. So what is the junior and the female? 6 students. 6 out of 26. Cancel common factor 2. So get 3 over 13. And question 8. Question 8 is in a class, there are 16 juniors and 11 seniors. 7 of the senior are female and 11 of the junior are male. If a student is selected at random, find the probability of selecting the following: a senior or a male. So first of all, we have to create this table. I'm going to erase it first. So total is 16 junior. So you write junior, senior, and male, female. Under the junior has 16 junior. 11 senior. Under senior put 11 seniors. 7 of senior are female. Female, senior. So put 7 here. 7 of senior are female. 7. And the 11 of junior are male. Junior, male, it's 11. So you put 16 minus 11, 5 is junior, female. 11 minus 7, it's 4. It's a senior and the male. Then add together 11 add 4. 15 male. 5 add 7, 12 female. Add together 15 add 12, 27. Or 16 add 11, also 27. That's the total. Then the probability of senior or a male is equal to, use addition rule, probability of senior plus probability of male minus probability of senior and the male. Probability of senior, total 27. How many are senior? 11. So 11 out of 27. Plus, how many male? 15. So it's 15 out of total 27. And minus how many are senior and the male? Senior and the male is 4. 4 out of 27 equals 11 add 15 minus 4 equals 22 out of 27. B, a junior or a senior. So since the junior and the senior are mutually exclusive event, the students is junior cannot be senior. So they don't affect each other. So the addition rule is just probability of junior add the probability of senior. So then what is the probability of junior? How many are juniors? Here is 16 juniors. Here has 16 juniors. So this is 16 out of 27. How many are senior? 11 out of 27. So we got 16 out of 27 plus 11 out of 27. Add together is 27 over 27, which is 1, which is 100%. You can the probability to get a junior or senior is 100%, because in one class the students either junior or senior, no others. And the C, a senior, find out probability of a senior and a female. So senior and the female, here the table here say senior and the female is 7. So it's a 7 out of total 27. So probability is 7 over 27. And question 9, apartment. An apartment building has the following distribution of apartments. Here's given numbers. I changed the number. It's not your homework question. Different from your homework question. I changed to 402055232. So this is a table. Now, first of all, we add together. 4 add 0 add 2 is 6. Six apartment on the first floor. Then 0 add 5 add 3. There are 8 apartment on the second floor. Then 2 add 5 add 2. Total is 9 apartment on the third floors. Then the column add together. 4 add 0 add 2. Total 6. 1 bedroom. In the building has 1 bedroom is 6 1 bedroom. 0 add 5 add 5 is 10. 10 apartments in the building are 2 bedroom. 2 add 3 add 2 is 7. 7 apartments in the building is 3 bedrooms. Add together total 6 add 8 add 9 total 23 apartments. Or you can add this side 6 add 10 add 7 also 23. Total 23 apartments in the apartment building. If an apartment is selected at random, find the following probabilities. A, it is not a 2-bedroom apartment on the second floor. So we're looking for probability not second floor 2-bedroom. So equal to 1 minus, which is not second floor 2-bedroom, not this one. And the others, you can choose the others, just probability not this one. So total is 1 minus probability of second floor 2-bedroom apartment. So total is 1. Is 23 out of 23. Total 23 apartments out of total 23. So total probability is 1 minus second floor 2-bedroom is 5 apartment. The probability to get second floor 2-bedroom probability is 5 out of 23. But here say not. So it's 23 minus 5. Total have 18 apartments. Those 18 apartments. So the probability is 18 out of 23. And B, it is either on the second floor or a 1-bedroom apartment. So either second floor or 1 bedroom. So we just use addition rule. So probability of second floor add probability of 1 bedroom minus probability of second floor and 1 bedroom. So probability of second floor total is 23 apartments. Second floor has 8. So the probability is 8 out of 23. Probability of 1 bedroom has 6. Here's 6. 6 1 bedroom, 6 out of 23. Minus probability of second floor and 1 bedroom. Second floor and 1 bedroom should be 0. Second floor and 1 bedroom should be 0. Should be 0. So this should be 0. 0 out of 23. 0 out of 23. So here answer is 14 out of 23. 14 out of 23. That's question 9. Question 10. In 2006, 76% of U.S. households, question 10, In 2006, 76% of U.S. households had cable TV. Choose 3 households at random. Find the probability that A. None of the 3 households had cable TV. So the probability to have cable TV is 76%. Put in decimal is 0.76. And probability of no cable TV is 1 minus probability to have cable TV is 1 minus 0.76 is 0.24. And the probability say 3 households, none of it has cable TV. It's probability none equal probability no cable TV times 3 times. So it's 2 to the power 3. So the no cable TV probability is 0.24 times 0.24 times 0.24 is 0.24 to the power 3. And you use calculator, you will find the exponent. You do 0.23, 0.24. Put this head key and put 3 to the power 3. You will get is 0.01382 and 4 significant digits. 4 significant digits. 4. This 4 is below 5. So it's truncate this 4 and you got 0.01382. And rounding. B. All 3 households had cable TV. So all 3 households has cable TV is equal to probability of have cable TV to the times 3 of it. So it's going to be power 3. So have cable TV probability is 0.76 and 0.76 to the power 3. To the power 3. So you use calculator. So you will do it's 0.76 to the power 3 equal. And you will get it's 0.43896 and round up to 4 significant digits. So it's 4 digits here. And this 7 more than 5. So the 9 add 1 is 10. Carry on 1. So it's 0.4390. Then C. At least one of the 3 households had cable TV. So it's going to find out probability at least one have cable TV. That is 1 or more than 1. It's a 1 household, 2 household, or 3 household. Be 1 or more is 1 minus probability of none of them has cable TV. So equal to 1 minus none of them have cable TV is we already calculate on A parts. Is this answer? So it's this one 0.24 to the power 3. So it's 1 minus 0.24 to the power 3. So minus and subtraction will get this. And 11. How many ways are there to visit 7 campus building? 7 campus building. So you can put first time you have a 7 campus building, so you have a 7 choice. And once you choose 1 campus building you visit, remain 6. Second time you visit, you have a 6 choice. And third time you visit the campus, the building, you have 5 choice. And then the fourth time you have remain 4 choice. 4 building, you have 4 choice. And remain 3 building you can choose. And remain 2 building you can choose. The last one, only 1 building you can choose. So it's a 1, 2, 3, 4, 5, 6, 7. This is the first visit. And that's the second visit. The first time you have 7 building you can choose. Once you choose that building, the second time you will not revisit that building. So it remains 6 building you can choose. And then once the two building chosen, and remain 5 building on the third visit, you only remain 5 building, 5 choice, and until 1. So you add those number together, 7 times those number together, 7 times 6 times 5 times 4 times 3 times 2 times 1, you will get this answer. And this we call 7 factorial. The 7 factorial is equal 7 times 6 times 5 times 4 times 3 times 2 times 1. This one we call 7 factorial. 7 factorial. Number 12. Question 12. 7 students are running for the positions of president and the vice president, and 6 students are running for secretary and the treasurer. If the 2 highest vote getters in each of 2 contests are elected, how many winning combinations can there be? So this position, one is president and one is vice president, 2 position. Then here has 7 students run the 2 positions. If for the president have 7 choice, 7 students, you choose 1 student as a president and remain 6 students for the vice president. So have 6 choice. And the other one is running for the secretary and the treasurer. 6 students. There are 6 students to run for secretary and the treasurer. Then for secretary have 6 choice, 6 students. Once you choose 1 student for secretary, then remain 5 students run for choice for treasurer. So those you tie together, 7 times 6 is 42. And here has 42 kind of outcomes. And here 6 times 5 has 30 outcomes. And combination together is 42 times 30, tying together 1,260 combinations.